Hey, welcome back to Ms. P House with Precal. This is Unit 1, Topic 4, Lesson 5. We're going to be talking about partial fraction decomposition. And we're going to start off with an addition problem. We have this rational fraction divided by this, added to this rational fraction. Now, remember, when we add things, we have to have like denominators. So over here on the right-hand side, I'm going to factor this into x plus 6 times x minus 3. That's the same thing. Now, we can only add this plus this if we have common denominators. So I'm going to have to multiply this side by x minus 3. We already have the x plus 6 factor. Now we have the exact same thing. Okay, so now we can, I'm going to simplify this. So this becomes x squared minus, that's plus 2x minus 3x is minus x. And then negative 3 times 2 is negative 6. So that's what this becomes, over x minus 3 times x plus 6. And then we're going to add that to the 6x over the exact same denominator. Then we can add them. So we're going to add this to this and keep the denominator the same. So we have x minus 3 times x plus 6 is the denominator. X squared, so negative x plus another x, plus 6x's, is 5x's, and then bring over the minus 6. Now the top can be factored again. So this is now x plus 6 times x minus 1, and I'm kind of running out of space here, over x minus 3 times x plus 6, and then we have the factor on top and bottom, x plus 6, and we're left with an answer of x minus 1 over x minus 3. A lot going on in that question, so let's take a look at another one before we actually get to the partial fraction decomposition. Very similar question what we had just done. We have two different denominators, so the least common denominator would be the two denominators times themselves. So we're going to multiply this side by x minus 1. Whatever we do to the denominator, you have to do the top because it has to be equal to 1. And then do the same thing over here. So times x minus 3 times x minus 3. All right, so 1 times x minus 3 is x minus 3 over x minus 1 times x minus 3. And then we're adding that to 2 times x minus 1 gives us 2x minus 2. Over x minus 1 times x minus 3. All right, so now we can add things. Now we have a common denominator. The factors on both bottoms were x minus 1 times x minus 3. And on the top, so 2x plus another x makes 3x. And then negative 2 plus negative 3 makes negative 5. And that can't be factored anymore, so there's no way I'm going to be able to reduce this. So that's going to actually be my answer right there. All right, so I know I do have another problem, but I really want to get into this, this idea of partial fraction decomposition, which is the idea of basically how this is my answer, and I'm going to try to figure out, well, what equation, what it would have had to have been to begin with. So what plus what would have given me this solution? That's really what partial fraction decomposition is. It's like this is the answer, and we want to figure out what rational plus what other rational would end up equaling this. And that's basically what it comes down to. So it's basically we're doing everything back. It's like factoring is kind of like the opposite of distributive property. So if you factor out the GCF, now you have what you would have had at the beginning of a distributive property problem. All right, so we have 5x minus 1 over, this is factorable, so this is x minus 5 times x plus 3. Okay, so what we do now know, based on the fact that this is factorable, is that we know if you look back at this question here, it's one factor plus something over the other factor is equal to the answer right here. So what I basically now know is that one of them is going to be over x minus 5, and the other one's going to be over x plus 3. Now, I don't know what the numerators are going to be, so I'm just going to use letters to represent that unknown number. So I'm going to use A for here and B for here. We don't know what these two numbers are. That's the whole point of this. We want to figure out what is A and B, so that what was the problem? What plus what equals this answer. Okay, so now in order to do that, we need to make the denominators the same. So we're going to have to multiply by x plus 3 over x plus 3. And over here, we'll have to multiply by x minus 5 over x minus 5. Now that we have the same denominators all the way across, basically we can just cross them out. So if all the denominators are the same, then we know that the tops must also be the same. So 5x minus 1 must be equal to a number times x plus 3 plus another number times x minus 5. Technically, a and b could be the same number. We don't really know. So now we're going to solve. So in this case, how we're going to solve is we're going to now choose a value of x. Now we're going to be pretty strategic when we choose that value of x. We want to choose something that's going to make one of these sides disappear. Sort of like you did with systems of equations. If you eliminate one of the variables, if you eliminate either x or y, then you can solve for the other variable. So I'm going to choose x equals -3. Now I'm doing that to eliminate a so I can solve for b. If I can get rid of one variable, then I can solve for the other. So I'm going to have to do the same all the way across. So that's 5 times -3 minus 1 equals. Now if this was -3, -3 plus 3 is 0, and 0 times any number, doesn't matter what a is 0. So a times -3 plus 3, that's going to be equal to 0, as we just said. And then b times -3 minus 5. All right, so we already said this gets wiped out. So this side ends up being b times -8. And over here, 5 times -3 is -15, minus 1 more makes -16. Divide both sides by -8, and you now know that b must be 2. Okay, so now we know part of the answer. We know that something over x minus 5 plus 2 over x plus 3 is the answer to the question. But what we don't know yet is what is a. So what I'll do is I'll do the same process, and I know I'm running out of space here. This time I'm going to choose +5. And the reason why I want to choose +5, okay, so the reason why I want to choose +5 is because I want to get rid of b, and 5 minus 5 would be 0. So therefore, we're going to make x equal 5 this time. So we get 5 times 5 minus 1, that's the left-hand side, equals a times x plus 3, which would be 5 plus 3. And then we're going to add b, I know I'm running out of space, and 5 minus 5. Okay, so now we know 5 minus 5 is nothing, so that's going to eliminate b. So we're left with what's left over here. 5 times 5 is 15. 15 minus 1 is 14. And then a times 5 plus 3 is 8. Hold on. All right, sorry about that. I did realize my mistake. So 5 times 5 is not 15, it's 25. 25 minus 1 makes 24. Of course, all right, hopefully the pen is working now. So 5 times 5 is 25, minus 1 is 24. Divide both sides by 8, and we get an answer of a equals 3. So now we know that it's 3 right here. 3 over x minus 5 plus some sort of number, which in this case was 2. 2 over x plus 3, and there's our answer. So this is the equation. So this is the same thing as this, only it's been decomposed. All right, so I got enough for one more question. Now, this question doesn't work out perfectly well, but we're going to do it anyway. So we're going to do the exact same process. So we look at the top and we ask ourselves, what can this both be factored? This can both be divided by, So this actually is not factorable. So this ends up being, the bottom is factorable though. So we have x, two numbers give you 24 and also add up to 5. That would be x plus 8. All sorts of pen problems here. Being multiplied by x minus 3. I gotta fix this pen problem. I think I got the pen working now. So we've got -9x minus 46 over, this is once again factorable. This is x plus 8 times x minus 3. 8 times -3 and 8 plus -3, it works. Okay, so now we know that it's going to be equal to a over x plus 8, and then added to another number over x minus 3. So we multiply both of these by x minus 3, and multiply both of these by x plus 8. Now I got the same denominator going all the way across. So now we can say that -9x minus 46 is equal to a number times x minus 3, and then being added to b, another number times x plus 8. So now I'm going to solve this equation by eliminating one of the variables. So I'm going to eliminate a by making x equal 3. So that's going to give me negative 9 times 3 minus 46 equal. Now this is going to cancel out, and I'm left with just b times 3 plus 8. All right, so negative 9 times 3 is negative 27. Negative 27 minus 46 more. And that's going to give me 4, 5, 6, 73. So negative 73. Nope. Is it 72? Sorry. 4, 5, 6. 6 on the 7. No, 73 is equal to b times 11. All right, so then I would divide both sides by 11, and there, I told you it's not really going to work out too well, but that's it. So that's going to be your b. So we already know it's negative 73/11 over x minus 3. But now we got to figure out, well, what is over x plus 8? And we're going to do that by now making x equal, we're going to use the exact same thing, but this time we're going to make x equal negative 8. So that would be negative 9 times negative 8 minus 46 equals, now we know this is going to cancel out, so we're left with a times negative 8 minus 3. All right, so now it's just a matter of doing the math. So this is 72. 72 minus 46 will be 20... 72 minus 46, 26, so positive 26, yep, 26 equals a times negative 11, divide both sides by negative 11, sorry about that, and that's what you got left over, 26 over negative 11. And this is going to be our solution. All right, and yeah, it didn't work out too well, but yeah, it's the exact same steps as we just done on the last problem. Thanks again for watching, and have a great day.